All right, geometry review 3234, parallel perpendicular lines. So let's get right after it. Number one says classify the given angle pairs as either, and you have alternate interior, exterior, same side, corresponding. First thing you need to realize is that I'm going to kind of extend these lines out. But these two parallel lines, when you're in between them, that's what's called the interior. And if you're outside of them, that's what's called the exterior. So that'll kind of help you out when you're making decisions. So let's look at the first one, numbers 1 and 8. So 1 and 8 are right here and right here. They're on the outside of the parallel lines, so they're exterior, and they are on opposite sides of the transversal. So remember this guy right here, he's called the transversal because he cuts across parallel lines. So for that first one, correct answer is B. All right, 3 and 7. So 3 and 7, if you look at those, 3 is right here, it's this big obtuse angle. 7 is right here, another obtuse angle. They are in the same position. One's inside, one's outside. So that's another thing that kind of tell you that it can't be interior or exterior because you have one inside of each. So that one is D, corresponding. Next one, number 4 and 5. So I'm going to kind of erase some of this stuff here. So number 4 and 5, 4 is right there, 5 is right there. They are both on the interior. So I'm kind of trying to make a decision between A or C. These are both interior, but they are on opposite sides of the transversal. So they're alternate interior. So that would be A. And then the bottom one there, 4 and 6. Well, 4 and 6 are on the inside. I have this acute angle here for 4. I have this obtuse angle for 6, so they cannot be equal. One's way bigger than the other one. But they're on the interior, and those are same side interior. So BDAC is how number 1 goes. All right, moving on down. Let's check out number 2. Now we got to find some measurements here. So I'm going to kind of redraw this off to the side and fill in the angles as we go. So I'm given 132. I should be able to get everybody else because I can use vertical angles to get this one, which is number 3. So that's 132. I can use a linear pair to get this one. If I subtract 180 minus 132, that leaves me 48. So then I can vertical angle this way. So that gives me 1 and 2. So I have a 48 and I have a 48. Now we just have to copy and paste down to the bottom. So because these two lines here are parallel, you know, I have these extra markings right there that show me that. I can then just copy and paste the exact same situation down below, which gives me angle 4, which is 48 degrees, and angle 5, which is 132 degrees. So just some basic relationships, parallel lines. All right, now we get into some algebra. So I have to actually set these up and solve these. So first thing I need to understand what pair they are. Well, the 19x plus 11 is this obtuse angle. The 20x plus 5 is this obtuse angle. So since those two are alternate interior, and alternate interior angles are always equal to each other, I'm going to set up an equation and solve it. 19x plus 11 has to have the same degrees as 20x plus 5. And now we start just getting into algebra world. I'm going to subtract 19x from both sides. And that gives me 11 equals 1x plus 5. My next move is going to be minus that 5 from both sides. And I believe we get x equals 6. Now, if I want to just double check it, I could plug it in. 19 times 6 plus 11. So that's 60 and 54. That's 114 plus 11. So I believe that's 125 for that angle right there. And let's double check the other one. Hopefully we get 125. So 20 times 6, well, that's 120 plus 5. Beautiful. They're both 125. So it checks out. All right, next problem, number 4. I see this 90-degree mark. So if this transversal is 90 degrees to one of the two parallel lines, it has to be 90 degrees to the other. So basically, I know that this expression here, negative 5 plus 19x, has to come out to be 90 degrees. So I'm going to just start solving for it. First thing is I'm going to add the 5 to both sides because my x's are already on only one side. So 19x equals 95. Divide both sides by 19. And that goes in there 5 times. So x equals 5. And again, I could plug that in there and verify that it works. All right, moving right on down, we're going to go to number 5, which is the big dog. Got a lot going on. 2 sets of parallel lines. So notice, you got some extra arrows up here. So those 2 lines are parallel. And then I have some extra on the other side. Sometimes it helps to maybe kind of redraw these and just focus on one line at a time, break it up into smaller chunks. So I'm going to kind of just focus on this line right here. So I'm going to kind of come down, and I was given that this is 72 degrees. So that should help me out because I know that these 2 angles right here are same side interior. They must add up to 180. So I'm going to subtract the 72, and that tells me that that angle right there is 108. So I now know what x is. It's 108 degrees. So we're done with that one. I also believe I can get 3y because 3y is in the same position as 108. Those are corresponding angles. So I can say that 3y has to equal 108. Divide both sides by 3. And I get 36. So there's my second answer. Y is 36. And now we got to tackle z. So I'm going to kind of redraw my picture. And I'm going to look at this line and this line as being my 2 parallels. And I'm going to look at this top line as being my transversal. Because notice that we have parallel arrows on those lines as well. So I'm kind of looking at it from a little different angle. And some things I already have the x part. I already have the x as 108. So that's going to help me out because this angle and this angle are corresponding. They're in the same position. So I should be able to set up an equation with these 2. And I should be able to make them equal to each other. So 3z plus 18 equals 108. And I'm going to minus that 18 from both sides, which hooks me up with 3z is 90. And then divide both sides by 3. And I end up with z has to equal 30. So there we go. We lock down x, y, and z. Just a little more complicated picture, more parallel lines, but same idea. Number 6. Same idea here, but now instead of having too many lines, I don't really have enough lines. So I want to look at, we have a parallel line running here and here. So I'm going to put some red arrows on there just to know those are parallel. Now let's focus on one transversal at a time. Let's just focus on this transversal. So if I'm looking at that one, and I'm kind of blocking all of this stuff right here out of my mind. I'm not even looking at it because it has no effect on the blue line. Angle 1 is alternate interior angles with the 76. Or another way to think about it is these are both 76 because of vertical angles. If you copy paste, I now see that angle 1 had to be 76 degrees. Now, going over to angle 2 and focusing on the other side of the line, let's kind of make our focus right here. I see that 119 and angle 2, they're same side interior. So same side interior, this one's acute, this is obtuse. They're not equal, but they have to add up to 180. So I'm going to do 180, subtract 119. What's that going to be? 61. So I think angle 2 is 61 degrees. Keep on going. Down to number 7. Very similar idea here, but now I don't have really any numbers. But I do have a parallel line with this guy. This line does not matter. There's nothing going on over there. But focus right here. And again, I see a slightly obtuse angle, a slightly acute angle. They're not the same. They're same side interior again. So those two have to add up to 180. So I'm going to set up an equation. X plus x minus 26 equals 180 degrees. You can just pretend there's a positive 1 there, so it really doesn't do anything. So I can just drop the parentheses. That step was kind of unnecessary. Let's gather up some like terms. 2x subtract 26 is 180. I'm going to add the 26 to both sides. And that gives me 2x equals 206. And divide. And I get x equals 103. And that's all we need to do. Find the value of x. So correct answer, 103. Moving on down. Number 8, I got to find x and y. Now the only thing I see here, they're trying to trick you because not all these lines are parallel. The only double set of arrows I see are these two. So those are the only two I can kind of use. And again, I'm going to try to kind of use separate pieces. So let me come up here and I'm going to draw the parallel line, and let's focus on this transversal first, and we'll get x. So looking at that transversal, I have an x plus 20 here, and I have an x plus 10 here. Well, those two form a linear pair. So with my x's, I can add those two angles up, and they have to make 180 degrees because they form a straight line. Cleaning up my like terms, I'll have 2x plus 30 equals 180. I'm going to minus the 30 from both sides. And that gives me a 2x equals 150. Divide by 2. And x is going to come out to be 75. Now let's go over to the y side. I'm going to kind of redraw my parallel lines again. And I'm going to now focus on this transversal. So this strategy of kind of drawing simpler pictures, I like to do that whenever I can. If things are looking a little cluttered or I'm getting confused. So there's y. Over here is y minus 40. Now these two, there's really no name for this pair. You know, if you look at your names. However, if I kind of use vertical angles here, those two y's have to come down here and be these two y's. And then the y minus 40's have to fill in the other 4 spots. I now can kind of see what the relationship must be. The relationship between a y and a y minus 40 are, they have to add up to 180. They have to make a straight line. So y minus 40 plus y has got to equal 180, or 2y's minus 40 has to equal 180. I'm going to add 40 to both sides. I get 2y is 220. And divide both sides by 2. And I get y equals 110. So kind of made a complicated problem into 2 simpler problems. Speaking crazy here. All right, number 9, write an inequality, solve for x. So we learned that if you have a line and you have a point that's not on the line, the shortest distance is the perpendicular. Okay? Perpendicular to a line from a point, that's the shortest distance. So I know that HJ must be shorter distance than JI. Alright? And this problem looks familiar. This might be the exact same one we did on a homework or something. 11 must be less than x plus 4. And I minus the 4 from both sides. And I find out that it looks like x has to be larger than 7. As long as x is bigger than 7, we're good to go. Keep on going. I think we have one left. Ooh, number 10, the big dog. So this was in your video notes. I don't think I told you how to do it in the video notes, but I showed you how you could do this in class. I think the easiest way, so I'm only going to show you one way here, is draw your own parallel lines, and then we're going to kind of use that to figure this thing out. So let's look at these two lines right here first. Let's focus on the top section. So if this is 134, this is 134. Subtract from 180, I'll get a 46 and a 46. Now, something that's cool that I can kind of use right here is this angle and this angle are alternate interiors. All right, they're same side, or not same side, they're alternate interiors, so they have to be the same. So you're 46 degrees. Now, if I play the same game on the bottom, these two have to be vertical angles, and I can now use alternate interior again with the bottom set of parallel lines using these two, and this is 56. And now the angle sum theorem says, hey, x is just going to be those two added together. So when I do 46 plus 56, I get a grand total of, what's that, 90 and 12, 102. So correct answer to this problem, 102 degrees. Now, it all started from me drawing in my own parallel line and making sure it was parallel. All right, and just to give you the name for it, that's what we call an auxiliary line. I draw it in myself. Now, there was another way that I showed you in the notes where you could have extended this line down, and it's kind of the same principle, and you focus on using a triangle. I'm going to go kind of quickly through this one. So if this is 56, vertical angles are 56. If I use this linear pair right here, this was 46. And now I can kind of use this angle and this angle. Those are alternate interior. And if you knew the exterior angle theorem, which we don't know yet, you could have used that right now to get x, but we're actually going to just try to figure out that all triangles add up to 180. So far, I'm at 102. So subtracting the 102 from 180, I get 78, which is here. And then these two form a linear pair. So basically, I'm going to just undo what I just did, 180 minus 72, and I get 108 that way. So either way, let me just make sure I did that right. 102, 78, 78. Check that. I screwed up right there, got going too fast. But since this is 78, I got to do 180 minus 78, which was 102. So just another way to do that problem. And I believe that is it.